Welcome back, everyone. We're going to be solving LeetCode 1762, buildings with an ocean view. So we're given n buildings in a line, and they give us this as an array of heights of size n that represents the heights of the buildings in a line. The ocean is to the right of the buildings, and a building has an ocean view if the building can see the ocean without obstructions. Formally, a building has an ocean view if all of the buildings to the right of that building have a smaller height. So we need to return a list of indices, which is 0 index, of buildings that have an ocean view, sorted in increasing order. So taking a look at example 1, right, they give us an array called heights with the heights of 4, 2, 3, and 1. We should output 0, 2, and 3. Why? Because the building at the 0 index of our array can see the ocean because there's no larger or equal to building to the right of it. And then the same would go for the second index, which is 3, and then the third index, which is 1. So how can we solve this? We know we're going to have an output array, so let's just get that out of the way right now. Now, we are going to use a pointer, just one pointer for this, and we will set it equal to the very last position in our heights array. So we will say pointer is going to be equal to the length of heights minus 1. Now, what do we want to do? We're also going to want to have a variable called max height so far. We will set it equal to 0. So on each iteration, right, we're going to go backwards. We're going to have a while loop. We're going to run this while loop while our pointer is not equal to -1, right? We're going to check the building at the pointer position. If that building has a height greater than the maximum height we have seen so far, then we know that building will have an ocean view, and then we will have to update our max height so far, and then we can also append the pointer position onto our resulting array. So let's do that. We'll say while pointer is not equal to -1, what do we want to do? We want to check if the heights at the pointer position is greater than the max height so far. If it is, what do we want to do? We want to append that pointer position to our resulting array. We also are going to want to set the max height so far equal to the height at the pointer position. And regardless of this, we are going to want to decrement our pointer by 1 each time. So let's run this, and we will print out our resulting array, just so we can see what we're working with. Let's run this. Okay, pointer, append res. This should be the pointer, not the res. Okay, so we can see we have an output array of 3, 2, and 0, right? But they expect 0, 2, and 3. So how can we get this in the correct order? Well, we can have another array. Let's just call it final. And we will say while the length of res is not equal to 0, we're just going to take the very last item in our resulting array, right? We're going to pop it off and then append it to our final array. So when we do this, we'll end up with the correct output. So we will say our value is going to be equal to res.pop, and then we will say final.append that value, and then we can just return the final array. So let's get rid of some spaces, and we can run this. And as we can see, we pass all 3 test cases, so let's submit. Perfect, it does run. So time and space complexity. Time complexity is going to be O of n, right? We have to, we're touching all of the elements inside of our array once, and while this is running in O of n time, That's going to give us an O of n plus O of n, which just simplifies down to O of n as a total runtime. And then the space complexity is going to depend on the length of our res array and the length of our final array. So we can say O of res.length plus final.length. All right, that'll do it for LeetCode 1762.